Everybody have a good weekend? Good, good, good. By a show of hands, how many of you guys have watched lecture 3 already? Oh, good for you guys. So here's what I'm going to ask you at the end. Was it helpful to do so? I think it will be. It's going to make a big difference. Same group of people, I'm guessing. How many of you started working on your week 1 turn-in? Good idea. Good idea to do that. Those dates come up quickly, and you remember my conservative multiplier of how long it takes to do things, right? Right, times 6. So whatever you think it's going to be, times 6, and that's probably pretty close. So try to budget that in, because that's going to make a big difference. There's nothing more frustrating than not giving yourself enough time to do the work, because then you're just turning in whatever, and that's not very gratifying and not a true representation of what you know and what you are capable of. So the more time you give yourself, the better it's going to go, I promise. All right, so wait, we got one more skating in. What's your last name? Glenn. Oh, there you go. T is better than 2. All right. Here we go. All right, so lecture 3, as promised, we are going to be talking about modeling today. So we're finally going to have the tools and the skills we need to start actually building stuff. So, and this is obviously integral to our week 1 assignment. So let's start talking about it. First thing that we're going to talk about is the idea of building in parts. And basically, this is what we're going to be doing. When we build objects in the real world, we make them out of many pieces. Well, we are building CG objects, but we build them the way the real ones are built. Build it like it's built is the mantra. So what you want to ask yourself is, if I had to make this object, how would I make it in reality? And then that's how you will make it in 3D. And there's a number of great reasons for that. We're going to go through those, and this will give you sort of a guideline or a set of guidelines to help you understand, well, how do I figure out how many pieces? Because sometimes it's difficult to tell. So obviously, this is something that we grade on, build it in parts. And here's something that's very important that you understand about building in parts. When I say building in parts, that doesn't mean just, yeah, it's made of more than one part, therefore it's built in parts. When I say built in parts, what I mean is it's built in the correct number of parts. Does that make sense? For every object you build, there is a range of, this is how many pieces this thing should be made of. So it's not what you think it should be made of in terms of the number of parts, but what we believe is the correct number of parts. So we're going to give you some guidelines to help you make that call so that you can make a good decision. So when you do build stuff, you're going to build the objects within the correct number of parts. Now, if you want some backup on that and you're thinking, whoa, it'd be really nice if I had something to help me out in terms of making sure I'm reading this object correctly and making it out of the correct number of parts, we actually have a parts guideline document, which basically lists out every object that you're going to build for this class and how many pieces ballpark it should be made of. So if you want to double check what you're thinking against what we have, you can always do that. Where do you think that document is? On FSO, where everything else is, right? So make sure you've got that as a guide, because correct number of parts is what that should read in your mind. How do we figure out how many parts to make things out of? And again, build it like it's built. So the idea is, in the real world, things are made of many different pieces. So what we have to do is make sure that when we are building things, we build them out of many pieces too. Because again, we're going for as close to reality as we can get. So in terms of my guidelines, how do I figure it out? One of the first things you can do is look for materials. Materials is an excellent hint on where there should be a separate piece. If you see a different material, then that should be a different piece. So if I'm looking at this dinette set here, this fast food dinette set, who can name for me a material that they see? What do you guys got? What do you got? Metal. There's definitely metal. You see this support structure in here? This thing that sort of builds all that. It's basically the spine of the object. It holds all the pieces up together. How about my digital friends? What do you got?
Wood.
Wood, definitely, or wood, depending on how you spell it, O-U-L-D and what have you. There is some wood-like material in there that represents the seats and the tables. Could be particle board, could be who knows what. But there's definitely wood in there, so that's going to be a separate piece. There's definitely some plastic in there. So if you take a look in terms of the materials, like right along here, there's like this plasticky material that they mount on the edges of these things so you don't cut yourself on the edges. So that's going to definitely be a separate material as well. And again, and therefore a separate piece. Yes. Oh, there's definitely some other materials in there. Like if you look down into here, these little feet that screw into the bottom, those are going to be a separate material. They're a different kind of metal. I'm not sure exactly what material they're using for it. But yeah, definitely, there's definitely a separate material going on down there. And those feet are used for leveling. You know, if you screw them up or down to get everything to level itself out, right? And when that doesn't work, you put napkins under there. A couple of people who've worked in restaurants out there. Yeah, that's the way it goes down. All right, so we've got those different materials out there, right? So again, anytime you see a different material, that should trigger your mind and say, that needs to be a separate piece. The reason being, we're going to be building separate materials, and we're making separate textures for those materials, and those textures and those materials all behave differently towards lights. So they're going to be made out of, in CG, a separate material, just like the real thing is, so that they all behave appropriately when light strikes them. And that's the whole important point too, making it built out of the correct number of pieces. All right, so look for materials. That's your first suggestion on how do I figure out parts. Next, sort of back to that build it like it's built. The idea, if you look at the original piece and you say, well, if I had to make this thing, how many pieces would I make it out of? For example, if you look at this chair, you can see that the back of this chair is made of 1, 2, 3, 4, 5 pieces of wood. So for just the back of that chair, we're looking at 5 pieces. So if it can be nailed together, screwed together, glued together, you know, whatever, hot glue, whatever it is you got to do to get those things to hang out together, even if it's just wedging it, if it's a separate piece, you've got to make it out of a separate piece. You build it the way it's built. Does that make sense? Okay, so number 2, look at the real thing. How do pieces actually come together? Are they soldered? Are they glued? Are they hammered? What are they doing to get those things to connect to each other? All right. Third piece of advice on determining what needs to be a separate part, parts that move. Anything that can be moved, anything that can be animated, all of these things are going to have to be separate pieces or they can't move at all. So for example, if you take a look at this Nerf assault pistol here, we've got this chamber here that holds all of the Nerf darts, right? That thing rotates to give you the next dart. So if that thing doesn't move, after my first shot, I'm a dead man, right? They're all going to gun me down. Yeah, better be a good one, right? Right between the eyes and then run home. So again, this is... Okay, I'm not sure where you play Nerf, but I've not had them any of them explode on me. Oh, okay. Oh, I see. So this piece here has to rotate in order to bring you to the next dart that you need to fire. This trigger, that's going to need to depress in order to release the spring that fires the dart. So that's going to have to be a separate piece for sure. This piece right here is the cocking mechanism, right? This has got a spring in it. And the whole point there is that's how we load the spring to fire the dart. So that's going to definitely have to be a separate piece. So again, anything that can be animated, anything that needs to move, that's going to have to be a separate part. And you'll notice when you look at this object, you know, we're talking about quite a few of those rules at once in terms of pieces that move, in terms of build it how it's actually built. Does that make sense? So several of these ideas come together in every object that you build. So make sure you're looking for those elements because that will help you determine how many pieces to make the thing out of. And that is definitely one of the things we are grading on. Is it made out of the right number or close enough to the right number of pieces? Make sense? Hell yeah? Okay, good. All right. So now that we've got this idea of I need to build it in pieces in our belt here, let's start talking about component manipulation with regard to shape change. Now, last class, we were playing with component manipulations. If you guys remember, we did the edge flow activity. And what we're doing is moving vertices around, moving edges around, and that changed the edge flow or the way the edges move across the surface of the geometry, right? But we're just kind of changing the way it looked in terms of the wireframe. Now we're actually going to change the shape of the objects, but we're going to be using the same components, vertices, edges, and faces. We're just going to use them differently now with a sort of a 3D capacity in mind. All right. Now, in terms of making these changes, again, you would think, oh, I need like special tools or something like that. No, it's the tools in the toolbox. It's just manipulation. Move tool, rotate tool, scale tool. Not any more complicated than that. So guess what we're going to do? Yes, yay, we're going to do an activity. We're going to play with the components and see how we can change shape. So first thing we do after we launch Maya is we set that project, right? So we launch Maya and then we set our project to what folder? Activity file folder. Absolutely, you guys are getting it. Great. Again, we only have to set it to the outermost folder because within that outermost folder, as soon as you open that thing up, you see all the little folders that Maya puts in every project that we make, and we see the little workspace Mel icon. So we don't have to set any further into the interior of that file folder structure. We just have to select that outer one. And thank goodness for that. So I'm going to have to minimize my little go to training thingy there. Okay, so I go to file and I set my project and I'm going to choose my activity file folder and hit set. And then file open scene and I want my shape change activity. That's the one I need. All right, now again, in the perspective view, we don't really do a lot of modeling initially, shape and form. We really do most of that in our orthographic views here. But I do have those images in there so that you can see them and how they relate to the objects we're going to be working with. Now, who can tell me from last class, what is it I like to do so that I can see through my geometry to the image behind? X-ray. Where's that housed? It's under shading. So I go to my panel menu here, shading, and I choose X-ray. And what that allows me to do is see through the geometry to the image behind. Now, granted, a black background is a little bit harder to see, but what I wanted to be able to show you is this selection box, because we're going to be doing a lot of selecting using that to speed our selection process. Much like we use different level components to speed up our modeling process, we can actually speed up our selection process by utilizing that same concept of the selection. So in terms of our objects, we'll go left to right. Right, so here's my object. It looks like a square. The shape I'm trying to hit looks like a square. So it looks like this view is done. Does that mean I'm finished? No. What do I have to do? Check the other views, right? So I'm going to go over to my other view over here. These objects are not in X-ray mode because they each have their own little panel menus. So I have to change this one to X-ray as well. All right, and I go to my first object and I see, well, this is a square. The object I have to change shape is a square. Okay, I guess that guy is done. So let's go to the next one. Grab this one here. Okay, the shape I'm looking for is a square. The shape I'm in is a square. Okay, I'm good in this view. But again, we go to the next view. Come over here. Uh-oh. Yep, change in shape. So what I need to do is I need to have my geometry kind of come in a little bit and then go back out. I'm trying to match this shape change here in the object. And what is of the utmost importance is that I have components in place to achieve that shape change, which was something you guys were asking about last class. Because if you look right here, you'll see, oh, I've got an edge here. If I don't have a component there, I can't change the shape of this object. Does that make sense? The thought process in your mind is, I see shape change, I need components. Does that make sense? Those two things go together. So in looking at this, I see, okay, I see a shape change, so I'm going to need components. And the good news is I've got components in this area. So I'm going to go to vertex mode by hovering over the geometry, right mouse button and choosing vertex. And I go select a vertex, and using my move tool, I move it. But when I do that, it looks like my vertex got duplicated somehow. I have extra edges there. What's going on here? I moved the component, but for some reason I still have component there. And what's happening is when you take a look at, when you look at my geometry, I only selected the vertex in the front and moved it. So it's not duplicating, it's just I've only grabbed the one in the front. So what you have to kind of get in the mindset of doing is we have to think in 3D as well. Does that make sense? So I have to imagine there is another vertex on the other side. So rather than doing a point selection of a vertex, which is what I did before, I just selected one, I'm going to do what we call a marquee selection. And that is hold down the left mouse button and create a drag box. And then when I let go, now I have the vertice in, oh, whoops, let me get them over here. I have the vertice in the front as well as the back. So when I make that marquee selection, I get both. So then when I go to my move tool and I move them, they both move together, and that actually affects shape change. So when I take a look at this in this view, I see that happening. I'm going to actually hide my image planes in this view because I feel like they're causing more harm than good. All right. Oh, that's my geometry that's doing that. But you can see when I move them together, I'm actually achieving some shape change here. So I can grab the two vertices on the other side, and again, using my move tool, just grab that arrow and move them. And then when I look at this object here, this geometry looks like the shape behind it. This piece looks like the shape behind it. So this must be the shape I'm going for. Does that make sense? Okay. So now we take a look at this one. And in looking at my geometry, again, I can see change in shape. You know, if something sticks out or something sticks in, that's change in shape. So I see this change in shape and I see edge looping. So again, wherever there is a change in shape, you need edge looping. Now, previously, when we were moving vertices around and trying to change the shape, we went into vertex mode, we grabbed the vertices, and we moved them. And we just kind of pulled them into place to achieve the shapes we needed, right? I can grab these guys and try to bring them in, try to grab these guys, try to bring them in. And it is kind of, it is changing shape, but if you take a look at it out here, you can see, oh no, I've made something awful here, right? So here's what I'm going to say. Yes, we do need to move those things, but we're going to move them in a different way. What we're going to do is, because this is a cylindrical object, it's the same on all sides, because if I look at this view and I look at this view, do you see how I see the same object there? So it's probably cylindrical, all right? So what I'm going to do is do a marquee selection of all the components on this level, everything. And if you take a look out here, you can see what I did. I grabbed absolutely everybody on that top row when I did that marquee selection. And now, instead of moving these things, I'm going to use my scale tool. And I'm going to scale, again, not from the side only, because that's going to give me some of what I need, but not quite. What I'm going to do is scale from the middle. And it sends everything out equally. So when I take a look at this object, you can see how that happens? Everything moves out. And I can go to the next row down and scale from the middle, but this time I'm going to scale them towards each other. All right. And again, you can see before, after, before, after. And all of a sudden, my object is matching in both views. Now you might be wondering, well, why am I using the scale tool to move things? That doesn't make sense. What you have to realize is the vertex or the vertice is the smallest component. There's nothing any smaller than a vertice. And you can't really make a vertice bigger or smaller. So if you grab several of these things and you scale them towards small, they're just going to move towards each other. If you scale them towards large, they're just going to go away from each other. Does that make sense? Because you can't affect their size. Good? Hell yeah? Okay. All right, there we go. So we got that guy going. So let's take a look at this one. Here's the next nutty little shape. And again, you see a change in shape here. So therefore, okay, good, I've got some components. But something to bear in mind, edges not only create changes in shape, sometimes edges help to hold shape. Now, if you look at the top of this thing, you'll see it's got sort of a point up here. And again, I'm looking at an object that is, pretty much cylindrical in shape because it's the same in both views. So if I come over here and I grab these vertices and I try to use my scale trick, I lose that narrow point on the top. So I don't want to move those vertices, but I do want to move these vertices. So I grab these guys and scale them out. So this edge loop allows me to change the shape of the object. This edge loop holds some of the shape of the object. Does that make sense? We call those holding edges. So these guys help to maintain some of the shape I've got. And again, you can see very quickly I've made some changes to this object, and it's pretty easy. So when you're dealing with cylindrical objects, this is a cakewalk. All right? Make sense? Okay, let's take a look at this last one, because this one's super fun. You're going to love it. Now, it's true, I could grab a row of vertices and scale them towards each other. Then grab this row and scale them towards each other. And that would give you both of the adjustments you need, right? You see it looks the same in both of these views. It's matching. But why not do both at the same time? Because you could do this row and then hold Control and Shift and grab this row. And then I could scale them towards each other and then use the scale tool to scale upwards as well and get them both to get into their spot. Okay. However, even faster than that, say it ain't so. It's so. This great trick, if you look at your keyboard, do you see there's a key called Control? Okay. Hold down the Control key and manipulate the Y axis only. And what you will notice is that your vertices come in on both axes simultaneously, but they don't go towards each other or away from each other like it happens when you just manipulate from the middle. The way this tool or the way this function works is when I hold Control and I'm manipulating the Y axis, the up and down one, what I'm telling Maya to do is manipulate this object on the other two axes. Ignore the one that I'm working with and do the other two. So I manipulate Y and it ignores Y, but it brings it in on X and Z at the same time equally. Does that make sense? So again, a tremendous time saver. So can I work smarter and that will net me some time? Absolutely. Because if there's, granted, I saved myself like a second, but if this is something you do 10,000 times, that's 10,000 seconds. Does that make sense? It does actually add up. So you want to make sure that when you're making these adjustments, you're doing the smartest adjustments you can, because there's a speed to the efficiency. So if you can actually work more intelligently and therefore save yourself time. Yep. I'll show you in this view because it's sometimes a little easier to wrap your head around. I've got an X-axis and I've got a Z-axis. I want it to come in on both of those simultaneously. So I hold the Control key down and I manipulate this axis because that will bring it in on X and Z at the same time. Hold Shift to grab them both or Control and Shift. Yep. And that brings them both in together. And like I said, it's a great time saver, especially when you're dealing with cylindrical objects, and we've got a couple of those. Beer bottle, so you can make those adjustments quickly and evenly, being the keys there. Speed and accuracy. All right, everybody have some success with this? Good, good. How about my digital friends? You guys doing all right?
On it, man. Yeah, George.
Awesome.
Watch this beforehand. He was going to bring up the Control thing.
Yes, absolutely. Well, and honestly, that's why I recommend take a look at the lecture beforehand, just because it'll, you don't have to like study it like your life depends on it, but just listen to it. Watch what I'm talking about, because when I talk about it again, it really gels sometimes. What's that? Well, I don't know about my jokes, but do you? They're all right, I suppose. I hope you find them entertaining, because unfortunately I can't do this any other way. So you're gonna have to put up with that. My apologies. What are you gonna do? All righty. So again, that's how we manipulate components, and this is how we affect shape change. So when we are modeling, we are manipulating the components to change the shape of the object. All right. Now, in terms of polygons, we're going to talk a little bit about the different varieties of polygon faces that we come across, because as soon as we realize that we can add components to geometry, because you know pretty much if we've got a shape change, that means we need components to do it. If we are adding components, we're going to start changing the kinds of faces that we have. So we need to understand the different types of faces that we have and how they work exactly. Now, in terms of faces on polygon geometry, they come in one of three varieties. We have quadded faces, and that's faces with 4 sides, exactly 4. We have tris or triangles, and those are 3-sided faces. And we have n-gons, which is anything over 4, so 5 and up. For our class, our objective is to have our geometry have as many 4-sided faces as possible. 3-sided faces here and there, that's okay, not a huge deal, because we're building inorganic objects, so it's not as big of a deal. N-gons are never okay, and that's not just this class specific. N-gons are bad. Now, just so that you can recognize them, let's talk about them. Here's a piece of polygon geometry, and you see this face up here. It's got 4 sides, and you can count them. 1, 2, 3, 4. 4 sides, that's a quad. Make sense? Okay. Now, this piece of geometry is a tri or a triangle. 1, 2, 3 sides. Pretty straightforward. This piece of geometry is an n-gon, and these things are the devil. Now, it's misleading because you might think, oh, but look, this thing's got 4 sides on it, right? It's a square. But here's the problem. It's got 1, 2, 3, 4, 5 sides, because this vertice right here makes that 2 edges, not 1. Does that make sense? So mathematically, that is a 5-sided face and therefore an n-gon. Now you might be wondering, well, what's wrong with n-gons? They seem cute. Why are we discriminating against these guys? It's not fair. Well, here's the thing. No, it's got nothing to do with cubism. To be honest with you, it has everything to do with math, because we are creating art, but we are using math to do it. Does that make sense? And 1 + 1 has to equal 2 or we have problems. So when it comes to this geometry, 4-sided geometry equals good math. Formulas check out. Things can calculate quickly and effectively. Does that make sense? When you start creating n-gons, you're creating bad math. You're telling Maya 1 + 1 is 27.8. And then Maya's like, whoa, okay, we can do that. How about I crash your file? So you wonder, why do my files crash? Why do my tools not work? Why are my renders taking so long? What? And n-gons is a huge contributor to these kinds of problems, because what it looks like is only part of the battle. It's got to be beautiful. Unfortunately, that's the given. It's got to be beautiful, but it has to be mathematically sound geometry also. Does that make sense? That's what makes it hard. Avoid n-gons entirely. Okay. Not even as much as possible. You don't want them. Yeah, fix it. Well, we're going to talk about how to fix it, because you might be thinking, okay, I'm looking at a cube. That's pretty straightforward. I can see where I've got an n-gon there. What if I've got a 10,000 polygon dragon? How am I going to figure that out? Well, the good news is there is a tool in Maya called the cleanup tool. We'll talk about that next class. And the cleanup tool will help find bad geometry so you can fix it. No, you fix it. So there's no problem there. So what happens is you got to be very careful of any setting in Maya where it says, let me fix it for you. Dangerous, dangerous, dangerous. We don't let the machine fix anything. But find it for me, that's a great use of a machine. Find me this, find me that. That's perfect. Does that make sense? Okay, so we will talk about that. But you want to make all the changes yourself for sure. All right, so along with four-sided faces, three-sided faces, and n-gons, something we have to talk about when we are adding components to geometry is a very important aspect of modeling, and that is edge looping and topology. Now, edge looping we talked about already in terms of, we were talking about edge flow and how the edges move across the surface of a piece of geometry. Well, when we are modeling, we want to have light, efficient geometry that describes shape and form well. And again, shape and form we talked about the very first day in terms of information that we need to be aware of. Who can tell me what shape is? What's shape? What is shape? Because we seem concerned with that.
It's a space that exists between connections of points.
You connect points together and it does form a shape. Absolutely. And what was the word that we use that's synonymous with shape in terms of recognition of an object? Silhouette. Absolutely. The shadowy outline of an object. Does that make sense? Shape is the shadowy outline. Now, it's 3D and depth related detail. What's that called? That's form. We're talking about depth related detail. That's form, surface detail on an object. Does that make sense? Okay. So when we talk about edge looping and topology, we're talking about hitting shape. We're talking about hitting form, but doing it in a light, efficient manner, very neatly, that makes your work look professional. Now, you might be thinking, well, how am I supposed to tell what looks like good edge looping and topology? Well, if you look at these two models, they're both of a marker. One of them has neat, clean, efficient edge looping, and one of them does not. So in terms of the modeling, I think you could probably pick which is which, right? The bottom one does not look like good edge looping and topology. So when you are looking at your own models and you see on the self-grade document it says good edge looping and topology, you want to be seeing the marker on the top, not the marker on the bottom. Because what you see is, you see these nice shading errors that Maya's giving us, that little dark area here and here. That's Maya's cute little way of saying, by the way, that's not cool. So it's already giving you a little bit of a warning. And if you look at the edge looping of this part of the marker here, it really looks very rough and awkward. So again, when we say neat and clean edge looping and topology, it's pretty obvious whether you have it or you don't. Does that make sense? So make sure, because we ask for that pretty much right away, look for, yeah, no, even in object mode, that would look pretty bad. You're right. But does that make sense? Is that clear? Edge looping and topology, what we're looking for? Yeah. Okay, because we're going to keep throwing terms on. We're going to keep adding them on a daily basis. There's going to be new stuff for you to add to what we're asking for with each turn-in. So that's why I say make sure you're writing it down and you know what it is. Because I give you a list, right? I tell you, we're looking for this, 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 and this. If you do it, you're going to do great. So the only thing that would stop you from doing well would be either A, ignoring that list, bad idea, or B, I don't know what the things on the list are. You know, you said edge looping and topology, you know, it might as well be in biophysics. I don't know what you're talking about. So in those two instances, you would not be successful. So make sure you know what these things are. That's key. All right, edge looping and topology, very important, because now we're going to talk about what I call the big three tools. Now, as you guys have deduced since last class even, if I want to create changes in shape, I need components to do it. And the question was, can I add components to a polygon object? Absolutely, and these are the tools that are going to do it. So when it comes to modeling, you must learn how to use these three, because pretty much modeling in Maya is these three tools. So we are going to be talking about the multi-cut tool, the insert edge loop tool, and the extrude tool. And they're all super cool. I think you're going to like them. All right, so I'm going to demonstrate for you the three tools and how they work. So please jot down the information as to how they function. We will talk a little bit about options as well. And then we have a fun little activity to do. And then Brian and I will walk around and make sure that you guys can be successful with that on the big three. So, but first, demonstration of, let's see. I'll just do a new scene. Okay. So let's take a look at the big three in action. Now, let's say I want, I hate to erase a nice graph, but oh well. It makes me sad. All right, so let's say I want to build a cute little house, right? And something in 3D. And in order for me to build this house, here, all right. Okay, so nothing fancy, but just a cute little house. Can you guys see that, my digital friends? Okay. All right. So again, not overly complicated, but I want to build a simple little house. Now, based on the components I have here, I can't really do that. I can try to, shrink this down. One of those cute, fun little three-sided house, which is great on the side of a mountain when you go skiing. I can have like a California style house, but that's not really what I imagine would be overly helpful in the New England area when it comes to shedding snow, rain, and other brutal weather elements on my house. So obviously, what I've got to work with here is not going to do it. So I have to add some components to create this shape. So the first tool I'm going to go to is under my mesh tools, and you will see what we call the multi-cut tool. And when I choose the multi-cut tool, you'll notice right away that my little cursor changed. What does it look like to you guys now? Do you see it? It looks like a knife, right? Some serious enthusiasm. Knife. And in terms of my knife, it is kind of what it is. It's a knife. It basically cuts edges into your geometry, like carves it right in. And you'll notice that as I bring my multi-cut tool to my geometry, like these little lightning bolts shoot out of it. Pew, 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 pew. It's trying to get to the corners, right? And if I go near an edge, the edges light up. The multi-cut tool works on edges. That's how it functions. And so what you're going to end up doing is if you come to an edge and you click with the left mouse button and hold it, you create this cute little blue dot, and it's got these little yellow numbers on it. And as long as you hold down the left mouse button, that cute little blue dot will slide along that edge. It can't go around corners, so whatever edge you select, that's what it is restrained to. But I can put it anywhere on there that I wish. And in terms of the numbers, what we are looking at is the percentage along the line that I'm on. So 50% is the middle, 0 is one end, and 100 is the other. Does that make sense? That's what those yellow numbers correspond to. Now, you might say, well, 67.3, 64, how am I supposed to find like whole numbers? That's ridiculous. If you hold Shift on your keyboard, you will move in 10% increments. So you can find exactly the stop you want. Now, do you think you might be able to set it for other increments? Absolutely. And that's going to be in the options box. We'll take a look at that. But in terms of the tool, by default, it goes in 10% increments. So you can go to the 50% mark, which is right in the middle, and then you let go. And what that does is it kind of plants that little blue dot there. And this is a baby vertice waiting to be born. It hasn't been born yet, but it's there. So I'm going to go to the other side, absolutely, because what I need to do is create an edge that goes all the way across this thing. And in terms of edges, I could put them anywhere I want. I can just click all over the place, and Maya will let me stick these things everywhere because Maya's a reckless, crazy person. But if you happen to lay down these little vertices where you don't want them, if you use your delete key, it's like going backwards in time. So you can turn back time and find a way, just like share. And so go back to that first one. So what I'm going to do is I'm going to go to the other side, click, and again, I can put this anywhere I want, but if I hold Shift, I can get to my 10% increments. And again, I could go and cut another one if I wanted to. If that wasn't where I wanted, I press what key to go back? Delete to go back. But once that's in there and I'm happy where it is, I hit Enter, or use my right click button on my mouse, and it literally cuts that edge in there. Of the utmost importance, after you create components, then you have to manipulate them. Does that make sense? It doesn't magically create the shape I want. I have to tell it what I want. Now, what's in my hand right now? The multi-cut tool. Do I move things with the multi-cut tool? What do I move things with? Move tool. Switch to the move tool. Does that make sense? Big, very common mistake for beginners. They're not looking at their cursor and what's actually in their hand, and they continue to cut whatever it is they're doing. Does that make sense? Here, let me help you with that. I got my knife out. So what you want to do is make sure you switch to your move tool, and then now with your move tool selected, you can make that little shape change and make your house. Does that make sense? Yes. So here's the issue. I have arrived at the correct shape, right? I got the house. It's just like the one I've always dreamed of. But the problem is I've got bad math here. 1, 2, 3, 4, 5 sides. And we just talked about that. That's a what? N-gon, right? And that's bad. So what we have to do is fix this thing. Guess which tool is amazing at fixing N-gons? Multi-cut, that's what it's for. It's amazing at that. It's kind of a slow tool to make a lot of change, but when you need to fix the topology and the edge looping of your model, multi-cut is great for that. So what I can do is get out my multi-cut tool again, go to Mesh Tools, choose multi-cut, and I'm going to recut this face. So I'm going to click on one edge, and I'm going to drag it until it won't move anymore. Gesundheit. As you recall, they don't go around corners, so as soon as I reach a vertice, it'll get stuck. And that's what you want to do. You want to hang it up, because what that will do is basically glue those guys together. Does that make sense? Then I can come down here and click, and again, I can hold the space bar and get to the 50% mark, and then hit enter or use my right mouse button. And now I'm looking at 1, 2, 3, 4 sides on that face, and 1, 2, 3, 4 sides on that face. Yes, but again, these two are okay mathematically. Does that make sense? All right, so now this guy, 1, 2, 3, 4, it's an N-gon. So what tool do we fix N-gons with? Multi-cut, exactly, multi-cut. So click and drag, come over here to the other side. Again, I'm going to hold shift, go to the 50% mark, and of course, if I had to cut this side of it, you know I got to cut this side of it because it's the same. I could, absolutely, if I wanted to. I could just keep going all the way around and cut it in. But what we see is some edges hold shape and some edges create changes in shape, but some edges maintain quadness, and that's all they do. Like these edges here, they don't do anything for the shape of my object. They don't change it in any way. But I need it because it makes my geometry four-sided. Does that make sense? So sometimes they have other work to do even though it doesn't look like it. So I can't just delete those because I don't think it's doing anything. Make sense? Okay, so that's the multi-cut tool, all right? And in terms of its options, of course, you go to the options box at the end, and here's where you get your 10% increment that you could switch to something else if you wanted to. All right, so let's look at this. Same idea. I want to build my house. This time I'm going to use, also under Mesh Tools, I'm going to use my Insert Edge Loop tool. Now the Insert Edge Loop tool, as its name implies, it inserts a loop of edges around the entire model. So what I can do is use this tool, and again it works on edges, come over here, click and drag and let go, and you see it like slices through my whole model all the way through it. Now you can see the edges are still selected, kind of like they're white hot. They just got cut in there, right? So if I go right to my move tool and move it, I move all the edges, right? I move everybody. But does that look like the house I made a second ago? Nope. So what I want to make sure I do is just select the one on top and move it. And then this gave me all the shape change that I need, and my faces are still four-sided. And that's the cool part about it. The insert edge loop tool is what I call a safe tool because it will not unquad your geometry. If your geometry is four-sided to begin with, it will be four-sided after you use the tool. It doesn't matter. So again, I call it sort of a safe tool because I can literally, as many times as I want to, drop edges into this thing and just make all kinds of totally bizarre shapes with it, you know, wherever I want to go. And this is all four-sided stuff. Does that make sense? Because it won't make unquadded geometry. Yep.
So it's easier for Maya to load like 2 squares instead of one like 5-sided.
It's not necessarily loading, but all of its calculations and everything Maya does is a calculation. Four-sided works great. For example, when it comes to rendering, right? That's the process where we take geometry and we figure out what it looks like and how it reacts towards light, reflections, refractions, and all that kind of stuff. When Maya is calculating out the surface of geometry, one of the many things it figures out is it calculates out the surface of the geometry. And it takes every four-sided face and it turns it into 2 triangles. So a square to 2 triangles is easy. You just draw a line through it. Boom, that's 2 triangles. Easy math for Maya to do. If you've got an n-gon, okay, now where do I draw those lines? How about here, here, here? No, I don't really like that. How about here, 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 here? Oh, no, how about here, 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 here? And it's going to try to calculate how that reacts towards light. Does that make sense? So the issue you run into is the math is bad, so it's going to A, take longer or crash completely. Does that make sense? Because you've created basically a untruth statement mathematically. So we're trying to work in four-sided faces. Again, triangles are okay because when Maya figures out geometry in terms of render, it triangulates geometry anyway. That's why when you have models that are built for video games, they're in triangles to begin with. That way you don't even have to calculate. Does that make sense? So point being, we work in four-sided faces because everything works better that way, including some of your tools. Like literally, you have tools like the insert edge loop tool that won't behave properly when you use them on n-gons. So you're like, what's wrong with my tools? Maya's awful. Maya hates me. No, Maya hates the way you model. Does that make sense? Because it's all math. No matter how pretty it is, it's math. So you got to make sure you're doing good math. All right. So again, insert edge loop tool, pretty neat, pretty fast, and it leaves everything quadded, which is great. Ching, 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 ching. Right? Yeah, looks like you could throw that at somebody. But anyway, point being, no pun intended, very handy tool, very fast tool, great for making quick changes in shape. All righty. So now we are on to the Mac Daddy of the modeling tools, the extrude tool. The extrude tool is under edit mesh though. It's in a different category menu-wise than the other guys. And of course, everything is on that toolbar too. Well, not everything, that's a misnomer there. There's a lot of them there, the ones you go to a lot. But in terms of the extrude tool, it works on a variety of different components. For example, you can grab a single vertice and extrude it if you want to. Edit mesh extrude, bonk. And you get the Rhino cube, which is obviously an n-gon, and that's a no-no. So again, the odds of you extruding a vertice are slim to none. I'm trying to think if I've ever, other than this demonstration right here specifically, have I ever extruded a vertice? And I don't think I have. Have you, Brian? I don't think I've ever done that. At least not when I was in my right mind.
Yes. Just for fun. Yeah.
Just for fun, for betting, you know. But you can also extrude edges if you want to. If you select a single edge and you do an extrusion, what you will find is that you create a single plane of geometry. And it's so thin, it's like paper, it's so thin. It has absolutely zero thickness to it, but it is a face that you can create. But to be honest, unless you're modeling paper specifically, you're probably not going to extrude an edge, but you can extrude edges, and that will give you those kinds of faces. Yes?
Just out of curiosity, wouldn't extruding like just the edges work? Like say if you were doing a dragon's wing membranes, wouldn't that be good for that?
No, you would still want thickness on it unless you were restrained to having only single-sided geometry, because you would want the geometry to have translucence in it, I would assume, if you're going to be using any kind of skin shader on it. Because for the membranous material, you would want the light to move through it. Does that make sense? And give away the nice arteries and capillaries and so forth within there.
Most 3D artists I follow, they've said that they've used like edges for it, which I didn't understand why.
Well, again, it has everything to do with if you're using double-sided or single-sided geometry.
Okay.
Yeah, and then that's just due to poly limits and stuff like that, largely. Again, you can extrude edges. That is a thing. But way more often than not, like 99% of the time, if not more, you're going to be selecting faces and extruding those. And the extrude tool is basically a two-phase tool. First, it creates new geometry, then you manipulate it using the manipulator. And that's the key, is you have to manipulate the manipulator to see and change the shape of things. But what's really cool about it is it's like magic. It just creates more geometry. And as many times as you do another extrusion, you can create more interesting shapes. And the extrusion doesn't have to go in or out necessarily. You can make a smaller face inside of a larger one, pull that out, do another extrusion and scale a smaller face inside of a larger one, and then do another extrusion and actually go inward with it and make objects somewhat hollow. And then you can do another extrusion and manipulate that to make a smaller face inside of a larger one, and then do another extrusion and bring it back out again. And then you can do another extrusion if you want to, and pull it way out and scale it, make all kinds of crazy shapes. And what you start to realize very quickly about this tool is it has got a lot going for it in terms of the things that it can create. And you can make all kinds of really interesting stuff with it super fast. And it's almost like magic. You just sort of grow whatever you need. It kind of acts like clay. If you could imagine, you just put more clay on whatever it is you're making. So the extrude tool just, grows stuff everywhere, and you can make all kinds of really neat stuff with it. Again, when it comes to modeling in Maya, it pretty much is the extrude tool. So we need to understand this guy, and we're gonna have a lot of practice with it. All right, so in terms of the extrude tool, what's going on and how does it work? Well, when you select a face or faces, because you can do more than one if you want at a time, and you go to Edit Mesh, Extrude, you'll see the manipulator, right? And in looking at the manipulator, you probably see some things you recognize already, right? What do you guys see? Move and scale right off the bat, right? I see the arrows of the move tool, and I see the cubes of the scale tool. And this is the important part about the extrude tool you need to remember, is if I want to sort of pull more material out, I'm going to use the arrows. I'm not going to touch the cubes. I'm going to use these arrows, and this is what moves stuff into place. Does that make sense? The move tool capacity. Now, I do have these cubes on here as well, which behave like the scale tool, right? In terms of scaling things. I also have this outer ring out here, which creates, you guessed it, when you click on it, a rotate capacity. So I can actually add rotations to my geometry. And again, with that extrude tool, I can scale, and incidentally, you guys remember that trick I showed you with scaling vertices to and from each other? Hold control and manipulate the axis you don't want it to move on. I can hold control and manipulate Z, and it moves on Y and X simultaneously to give me that shape, which is the same as the shape that I had to begin with. The extrude tool kind of works. Did you guys have that toy? It's a Play-Doh thing. You put Play-Doh on the top of it, and you pull down on the little handle, and the Play-Doh shoots out of the bottom, and whatever you put in front of it, that's the shape you get. So if you put like the half moon, you get a half moon thing, or girders, or whatever shape you want to make. The extrude tool works like that. So for example, if you, here, let me bring this back out again. If I've got a square shape here, when I do the extrusion, I'm going to get a square shape. If I make a smaller shape inside of a larger one, I'm going to get a smaller shape that comes out of there. if I change the shape of this object, let's say I grab these two vertices and I scale them towards each other, right? I make sort of a diamond shape. Well, guess what? When I extrude that, I'm going to get a diamond shape. So literally, you can create any shape you wish and extrude, and you're going to pull that shape out of whatever it is you're modeling. Does that make sense? So it's pretty neat. Again, you can make just about anything, which makes it a very powerful tool, right? Yeah. Or a turret for a really bad sci-fi movie. Exterminate, exterminate. That was not a dig on Doctor Who either. That's a great show. But anyway, in terms of the extrude tool, it does a lot of really cool stuff. So we definitely have to learn how to use this guy because it's the most important one for us to figure out. So we're going to do a little activity here together, and we're going to play with that tool. And I even have another activity that is extrude tool specific so that we can play with that. So what we're going to do is practice our big three tools using this file. So I go to File, Open Scene. Again, I've already set my project, so I don't have to set it again. Maya knows I'm working on my activities. And I'm going to go to my big three tool activity and open that one up. And you will see I have three cute little houses for you, right? This one, which I made with the multi-cut tool. This one that I made with the insert edge loop tool. And this one I made with the extrude tool. And you can't mess with them. I made them bulletproof, so don't worry about it. But they are meant to be examples for you. So what you can do is create three cubes. So click and make one, and then move that to the left. Click it, make a second one, move that to the right, and then click it one more time to make a third one so that you have three cubes. And the goal is to build these three houses. Now the first house you will build out of straw. No, the first house you will build out of using your multi-cut tool. So again, what you want to do is get out your multi-cut tool, click and hold shift to get to that 50% mark. Click and hold shift, get to that 50% mark, right? And when you get it where you want it, click with the right mouse button or hit enter, either of those are fine, and that'll give you the edge that you need. And then you go to edge mode, select it, and move it into place. And again, I know it's an end gun, that's okay, we're just playing right now. We're not going to burn in hell for all eternity. So we will leave that there like it is. Well, maybe some of us will. Then again. All right, so again, the second house, we want to build this one out of wood. So we use the insert edge loop tool. Insert edge loop. Click and drag, and then let go when you get it where you want it. And remember to click off into space to deselect all of those edges. So you just select the one on top, and then again with your move tool, pull that one into place. And then we go to the very last house, and this one will be made of titanium. And so we select the face on top, and we go to Edit Mesh and choose the Extrude tool. And this one, we're going to pull up, and we're going to use our Control key trick. We're going to hold down Control and manipulate the blue axis so that it will move on the red and the green one simultaneously and give us an evenly spaced roof. Now it's true, if I wanted to, I could just, scale it with the green cube and then scale it with the red, but then I don't know if I did it exactly the same. So that kind of affords you some precision if you hold Control and manipulate the Z axis. And then you just in terms of the accuracy of the move, it's a little bit easier to do it like that. So Brian and I are going to walk around and make sure you guys can do this, and then we will move on to some more fun stuff. The last one is the Extrude tool. It's under Edit Mesh. Yep, you got to go over just a little bit. Extrude, yes, extrude. Good, good, good. How you doing? Okay, you selected the face. Now you got to go to Edit Mesh and choose Extrude. There you go. Now, if you grab the blue arrow and pull it up, you'll see you have more geometry, right? And the cubes will make it larger or smaller. So once you let go, you'll have the manipulator again. Question? Are you good? Yeah.
Why is it also doing it on the bottom? Did I select the whole face?
I think it maybe accidentally selected that as well. Let me see. Hit the delete key. Hit the delete key in the upper right there. Let me see. Go backwards. Ooh, that's cool. Do this. Select that in object mode and delete that cube and make another one. Because I think something's amok there. You have to select it in object mode. Right mouse button over the geometry. There you go. So use object. Now hit delete. Yes, you can't delete an object by deleting all of its components. It has to be in object mode to delete it. But try that. All right. Now go into multi-cut tool, mesh tools, multi-cut. There you go. Now get in close. Oh, kind of far away. There you go. Now Maya is a two-handed application, so you're going to have to work those keys over there. There you go. Oh, I see. I think you might have some reflectivity function turned on with your multi-cut tool. So let's go into the multi-cut tool and reset its options. Just go to multi-cut and go to the options cube at the far right. Keep going. Boop. And hit reset tool. There you go. Because sometimes there's like a mirroring capacity on there. And I think you may have activated that. Looks like it's still doing that. Interesting. Do me a favor and double click on your select tool. Reset that. Okay. Have you restarted Maya recently?
Yeah.
Try restarting it. Let me just see, because I think you've got a little bit of something going on there. And just like we need sleep in order to be at our best,
Yeah.
Maya and your laptop also needs to sleep. So if you just close it, that's not really sleeping. So it gets crabby. So try restarting Maya and see if you have any better luck after you restart it. Sometimes that makes a difference. How you doing? Oh, I'll be there in a second. How you doing? Good? Excellent. Very good. Nice. Good houses. I like the neighborhood you live in.
I seem to have run into an issue.
Uh-oh.
The issue is that I've announced it.
Oh, so your life is brutal.
Yeah, so my life is very fictitious.
Well, I would recommend definitely mouse or pen next time, but that's okay. You can struggle through it today. The pen that comes with your tablet?
Oh, I made the switch from like game design to game art, so.
You should have still gotten a tablet or a, what do you call it? One of those tablets, and it comes with a pen, Intuos.
I'll talk to.
Talk to your student advisor first, because you should be issued one of those. But yeah, so just go to edge mode and try to select that edge on the top. 2 fingers on the pad. There you go. Mm-hmm. Well, it looks like you did because you did it. Yes, I had to cut through here to make that 4 and 4. Multi-cut, same tool. You just click here and drag, and then click here and drag. Just like you made that line on the top, but now you do it on the front. Mm-hmm. And then go down to the bottom. Wait, right there. Now let go. Now go down to the bottom. No, a little further over. Click. Right? Does that make sense? That's how that tool works. Good. All right. Looks like you guys are doing terrific. Good, good. Yes.
So I clicked on the top line like you said.
Mm-hmm.
But when I click on this guy,
Mm-hmm.
well, only like
Mm-hmm. Well, I think you may have had selected an edge and extruded the edge. So just delete that cube and make another one and try that again. Yeah, right mouse button over the geometry and put it into object mode. 2 fingers on the trackpad. Choose object, upper right, and then just hit delete. Now make a new cube and try it again. Because it looks like what you did was an extrusion on an edge. I think that's what went amok there. All right, how'd you guys do all up here? Good? No. Oh no. No, that's fine. Okay.
Yeah, it's the third one.
Okay.
I'm kind of confused.
Okay. So you selected the face. And then what's the tool we're doing?
Extrude tool.
Extrude. Right. Now, did you grab the arrows to move it?
This one?
Mm-hmm.
Yeah.
All right.
Mm-hmm.
And then did you use the cubes to scale it?
Like,
Yeah. Well, go out to the cube
okay.
and grab it with the left mouse button and push it. And then do that with the red one. Make sense? No, there's nothing confusing about it.
I'm here. This is where I'm at.
Yeah, grab the arrow and pull it up. I promise. Just the blue arrow, not the cube. Ta-da! Well, something you will come to realize is Maya is definitely a touch. It's a finesse. You got to get a feel for it. Do you drive stick at all? A little bit? Not necessarily well. But the point is, when you're driving stick, there's definitely a point where the gas has to take over and the clutch has to release, right? And every car is different. It's so hard to find where that happens. That's a feel. After a while, when you feel that, you can do it and you don't even have to think about it. Maya is the same. There's a touch to it. And just in doing it, you're going to get better at it. You won't even have to think about it. But at first, it's tricky. Yes. Sure.
I can't move my mouse anymore.
Oh, yeah, that's interesting. Yeah, what I would say is, yeah, shut down Maya because it seems like it's freaking out. And you might need to restart your laptop as well. Oh, I was actually going to tell you guys that. But thank you for reminding me. Yes, but you have to pick the individual object. We'll go into the level 1 folder and then choose the object you want to build. One click, just one click, and then set. Then when you go to File Open Scene, it will open the Start Scene.
Because for some reason, the last time I did it, I somehow was able to choose every object in only one project I set it up.
You should only be able to get one because it's on an individual basis. Does that make sense? Because each of them have their own pictures that we use as reference. It's okay. You got it right now. That's what matters.
I got some of the objects, but like they were mostly made with only edge loop tools, so they don't have separate objects for them. So I'm gonna have to do them all again.
Well, no, if it's made of one material, like the beer bottle is one material. It's glass. So that would be made of one piece of geometry.
So like the ladybug is only
One piece of material. It's basically like a pool squirt toy. So it's rubber. One piece of geometry that fits. Okay.
I think it's a lamp or something like that. Not a lamp. I forgot the name in English.
Okay.
Like a light bulb. Yeah.
Oh, okay. Yeah, I don't think there's a light bulb in there, but
In one object only.
yeah, very few of them are one. The ladybug is one of them. The beer bottle is one. But those are there are very few that are made of just one material. Yep, remember to hit delete to go back. There you go. Why don't you let me sit down for 1 second. Let me see if I can see what's going on there. Oh, and incidentally, you need a real 3-button mouse. That's not going to work. This is definitely not going to work because this is not a true 3-button mouse. Does that make sense? So it's not getting enough information, which may be part of the problem. But let me see if I can see what we've got. All right, there. No, I turned it off. You did have symmetry on.
Oh.
Yeah, it's working fine now. You had symmetry turned on, that's all.
Okay.
Yeah, no worries. But you definitely do need a true 3-button mouse. It'll make your life so much easier. Yes. What's that?
You're talking about the mouse?
Yes. Mm-hmm. Oh yeah, any 3-button mouse will work. Like you can buy like a $6 3-button mouse at like Walmart, and that's fine. That's all it takes. Oh, okay. All right. Okay, well, if you bring it to lab, ask Marcus to take a look at it for you. He's very good at configuring those things. He might be able to help you out. But yes, the mouse is super cheap, so. Yes. Well, this thing I would accept as 2 or as 1 is fine. Does that make sense? Because if you were to make that thing out of glass, that's how you'd have to make it. Yeah, no worries. All right, guys. So it looks like we're doing pretty well with the extrude tool. And like I said, you can see it's a little bit tricky. So we have another exercise that will help you out with its use. And I think you will find that it will help you out tremendously in terms of your understanding of that guy. Now, something that is very important for you to understand about the extrude tool is normally, as soon as I show everybody the extrude tool, they're convinced that the extrude tool is the answer to everything. They're like, oh, I need a change, a shape and change. Oh, I need the extrude tool. I need to add more components on here. It's got to be the extrude tool. My bank account's not balanced properly. I need the extrude tool. And then the truth of the matter is it doesn't fix everything. Sometimes what you really need to do is just manipulate the components you already have. Does that make sense? I want you to think of components as like money. It's a budget that you cannot exceed. So you don't want to just arbitrarily keep adding components if you don't necessarily need them. So what we're going to talk about now is this other exercise that I created for you guys, and I think you're going to like it. But basically what it teaches you is, do I need the extrude tool or should I just be manipulating the stuff I've already got? Does that make sense? Because there's an important distinction there, when and where to use that tool. Because as you can see, it's a bit unwieldy. So what we're going to do is take a look at this other extrude tool exercise. So I'm going to open this this new one. And again, any exercise you want to practice again, feel free. Don't save it. Work on that again. You don't have to, just do this once and, well, I didn't really get it, so I guess that's it for me. Well, you can go back and do this anytime you want to. Oh, incidentally, a question came up. How do you get those cute blue lines on there? Even though it's in shaded mode, I can see sort of the wires. If you go to your shading menu set, wait, I got to close this because Maya's single track mind. And I understand that. If you go to shading, you'll see we've got something called wireframe on shaded. And that's what allows you to see the edges even though you're in shaded mode. So that's kind of a cool capacity, especially with some tools that we're going to be showing you guys later. But anyway, so let's go to File, Open Scene, and I want my manipulate components and extrude activity. It's the longest file, so get that one, the longest file name. And this is that one that again tells you or teaches you the difference between, am I changing shape or am I using the extrude tool? So in this particular exercise, we've got 2 pieces of geometry. The lighter colored yellow geometry is the objective. The darker green colored geometry is what you have to work with. So what you have to decide is, what do I have to do to make the green one look like the yellow one to its left. Does that make sense? Objective, what you have to work with. So in looking at this first object, I can see, okay, this is cylindrical and the object I have is a cube. So the answer is not extrude tool. Okay, again, extrude tool is not the magical make everything great thing. This instance, I really just have to move the components I already have. So if I grab the edges here on the corners and I move them, and I'm going to use my top-down view because it's easiest to see. Here's my cylinder. All I have to do is move my edges sort of inward, and that creates rounding. Does that make sense? So again, I'm going to come over here and grab these guys, this other corner, and go to my top view. And again, just move them in, and then move them in that axis as well. And you can see I'm starting to create rounding. So this isn't the extrude tool, it's just me moving the components that I've already paid for and not going over budget with my polys, right? It's creating rounding, right? Again, anything that's rounded shouldn't have corners, so that's your first giveaway of what needs to move, right? And I can make things more rounded. Now you might be looking at these two and say, well, this one looks very uniform and yours looks like it was put together with a monkey that hasn't slept in a while. So how do I make it look better? Because that's awful. Well, here's what I'm going to do. I'm going to let those pieces go back out again to where they were before I messed with them and made them look terrible. And I'm going to use my control with the extrude tool or with the scale tool trick that we learned early on. So I'm going to grab all of my corners, right? Every edge, all 4 of them, just like I did before when I moved them one at a time, right? And then with my scale tool in place, you guys remember what the control trick was? What do I do? Hold control and manipulate the axis that I don't want them to move on, right? I don't want these edges getting taller or shorter, but I want them to move towards each other on both X and Z. So I hold control and manipulate the Y axis, and they move towards each other evenly. Does that make sense? That looks much more rounded. So again, it wasn't the magical extrude tool that did that. It was just me being smarter and just moving the components I already paid for to get the shape I need. Make sense? Okay, so let's take a look at the next one. The next geometry conundrum. So I've got a change in shape here, and it's a pretty dramatic one. This is what I've got to work with. So in terms of making this change in shape, I need to make what I describe as a smaller face inside of a larger one. So the way I'm going to accomplish this is I'm going to go to face mode, and I'm going to hold shift after I grab all 4 of these faces. And I'm going to do edit mesh, extrude. Now again, I can manipulate the green cube and then do the red cube, but that doesn't guarantee me that it's going to be a nice uniform change in shape. So we can use that fun little trick that we learned, hold the control key and manipulate the blue axis, and it will move in on the green and the red ones simultaneously. And it will make a shape that is even in the middle. Now, in terms of that shape, once I make it, if I pull the shape up right away, I'm back to sort of my Pizza Hut roof. But when I look at what I want, that's not what's happening here. It's very flat and then it very abruptly goes up. So what that's telling me is since I've got that sharp angle there, I have to do an additional extrusion. So rather than pull this up, what I'm going to do is once I create the smaller face inside of the larger one, I'm going to do another extrusion. And with that in place, then I get that dramatic change in shape and the bottom holds its shape. Does that make sense? Smaller face inside of a larger one, and then do another extrusion and pull that up. Okay? Now, another level of complexity. Here we go. If we look at this third one basically combines the first 2 because I've got this component, this thing is sticking up out of the top, and I've also got the rounding going on. But the difference between the two is when do I round it? Because you can do it one of two different ways. So again, if I want this shape change, what did I do to this one over here? If I want to create that dramatic change in shape, what did I do to this guy that I'm going to have to do to this one? I'm going to extrude for sure. What was the first thing I did? What did I select? All the faces on the top. So first I'm going to get all these guys, and then I did the extrusion, edit mesh extrude. All right, I held control and manipulated the blue axis to give me this shape inside here. Now here's where it gets different. I'm going to have to do a second extrusion to pull this stuff up, right? But the question is, do I manipulate this object first and then do the extrusion, or do I do the extrusion first and then manipulate? Because I can do either one. You want to see extrude first? All right, so first we'll do extrude first. Again, if I just pull this straight up, that's not what I want. So I'm going to have to do a second extrude. So I go to edit mesh, I do another extrusion. I pull this up. So now I've got this shape. So how did I get this to be round?
The edges.
I grabbed the edges, and what trick did I use? Scale in conjunction with the control key. So I'm going to come back over here, and I'm going to grab all of my corners in terms of the ones that go up and down. Using my scale tool, again, I'm going to hold my control key and manipulate the y-axis and bring it in on the other two. Does that make sense? Now it's round. Now, do I have to do that then? Not at all. Here's the same game, right? I've got that square face. If I pull this up, what shape do I get? If I pull this face up right here, these four, I'm going to get a square. Well, what if I grab the corners here, Gesundheit, scale them towards each other to make it round first? What do I get from that?
You get a round surface.
I'm going to get a cylinder basically, right? Because this is already rounded. So if I do an extrusion here, because remember we're talking about that Play-Doh thing, right? If it's already rounded, when I do my extrusion, guess what I get? Rounded. So it doesn't matter which way you do it. They're both the same thing. It's about creating curvature. And if you've got enough components, you can do it. But you got to have enough components to create curvature. Because if you remember when we were talking about polygons, between 2 points, you can only have a straight line. So if you want something to appear curved, you have to have a lot of straight lines. And eventually, it will appear curved. Does that make sense? Okay, so that's how polygons work. All right, so here we are, we're getting into some more nutty stuff. This object is cylindrical to begin with, and it's got a smaller cylinder inside. So this is relatively easy because all I have to do is grab this face, edit mesh extrude, make a smaller face inside of a larger one, right, just like that. And then just do a second extrude and pull it up because it's already a cylinder. So it's going to make more cylinders unless I do something else with it. And extrusions don't just go out, sometimes they go in. So for example, if you grab this face and you see I need to make this hollow, like, oh, I don't know, beer bottle jar, things like that, I can do that. Same game, edit mesh, extrude. I make a smaller face inside of a larger one, and I'm using the control key so it moves in evenly on all sides, right? But I don't just push it in, because is that the same? No. So what do I have to do? Another extrusion, right? Edit mesh, extrude, and this time I just pull it in. It's an intrusion, right? Intrusion alert, intrusion alert. So you can see Extrusions go both ways, in, out, whatever. Doesn't make any difference. Does that make sense? Get a hell yeah on that? Okay, good. So again, this is another great exercise for learning to use the extrude tool well. So you guys can go to lab and be like, hey, Marcus, have a seat right here, buddy, because we're going to work this thing out because I'm struggling with it. That's when you do that. Does that make sense? Make use of that time. Ask questions. Have people work with you. Don't be shy. You need to learn this stuff. I don't know if you guys are familiar with how the classes are set up, but the way it works is 3DF and the next class is called model creation. But 3DF and model creation are two classes where you are learning intense amounts of modeling. Then you go into a portfolio class. And the idea of the portfolio class is now that you've learned how to model in these two classes, now you're going to build for me professional level assets. I want you to build, whatever I ask you for. Make me these keys, make me my laptop, go model my car. Now you won't have to do a car, but and basically they want them to look as close to real as possible. And the portfolio class isn't really an instruction class. I mean, they'll give you critiques and feedbacks and suggestions and that kind of thing, but they're not going to teach you new material. At that point, you need to be able to execute. Does that make sense? So the tools that you learn in 3DF and model creation, you put those in your utility belt, and that's what you use when you get to the portfolio class. Does that make sense? Okay, so you really need this information and you need to own it, not borrow it, own it, so that you can execute when you get to the portfolio class. So that's why I say, don't take it lightly. Take it seriously. This is important stuff that you need to feel comfortable with in order to be successful. So if you need to do these exercises again, do them again. You need to do them with Marcus or Sarah, do it with Marcus or Sarah. You're more comfortable with your friends, maybe. Hey, then everybody get together at your house and we're having pizza and we're going to do the extrude tool. So, get together and work on this stuff. It's a lot of fun, really, because everybody knows something and you can kind of share your information and practice. And I've said this about a zillion times, but if I could make you guys work together outside of class, I would, because it is definitely one of the best ways to do it. I know it's easier to work by yourself because you work on your time and you can be shy and introverted, not worry about anybody judging you, but that's not reality. You need to kind of shake that off, get comfortable with working with other people and realize you're all in the same boat. You're all struggling with the same stuff. Some of you know a little bit more, some a little bit less. Some of it pick it up a little bit easier, some of it a little bit slower. That's fine. You all work together and you get through it. You work as a team because that's the way you do in the industry. You work as a team. So great skills and learning how to work together. So there's a lot to be learned from working together. But unfortunately, I have no control over that. So you're not responsible for a pizza party now. But if you guys wanted to have one, I would suggest it very highly because it does work really well. All right. So that being said, yes, skill check. Now, the skill check for lecture 3 is we're going to be modeling the jar. Now, if you guys recall, we did a skill check for lecture 2, but we were blocking out the jar. So that's different. Block out, that thing's going to be made of probably 3 shapes, at maybe 5 at the most, but it should be around 3 or 4. Pretty simple. We just created some shapes and kind of shoved them together. Now we're going to model the jar, which means we are going to use the ideas of build it like it's built, which means we're going to be using tools that create components like the insert edge loop tool, like the multi-cut tool and the extrude tool. So this is really modeling. Does that make sense? Okay. So let's take a look at how that would go down or might go down. All right, so first things first, we set our project, file, set project, and I'm going to choose my skill check file folder because this is a skill check. All right, and then this time I'm going to open up, again, my jar asset start, same file I'm going to start with because it really doesn't make any difference. We're talking about using image planes, but now I'm going to be using modeling tools like we learned today. So first things first, we're looking at the jar here. If I was going to draw it, I would use a cylinder. So of course, if I'm going to model it, I'm also going to use a cylinder. Right? Get that guy into place. Again, X-ray is your friend. You can see through the geometry to the image behind. Right? Nope, it's true. I'm not doing anything you can't. All right, slide that thing into place. All right, start lining stuff up. Go to this view. Again, just because it looks good in one view doesn't mean squadooch. It's gonna look good in all of them. So make sure you get it in there. Now this time, I want to make this geometry taller, and I know somebody was asking me, how do I move just one side? I don't want to scale both sides at once because it's the devil. Well, you can go to vertex mode, grab all the verts on top, and just move them right up there, right? So let's see, let's do this using the insert edge loop tool. Now let's do it with the extrude tool first because that's going to be easier to demonstrate. Okay, so in terms of this object, the next big detail I encounter is this sort of lip thing, right? So I need to create that. So what I'm going to do is grab all the faces on top, right? Now, I could try to do like a drag selection, and you'll see I'll start grabbing some stuff on the side, which is just frustrating as all get out. So something really cool you can use is the paint select tool. And what's really cool about this thing is when you click on it, you basically have a paintbrush in your hand, and that red circle is your bristles. And you can make the bristles bigger or smaller using the B key, as in boy, in conjunction with the middle mouse button. So you can make it big or small by moving your mouse like that. And what I'm going to do is choose faces, and I can literally just paint the faces I want to select. All right, and it doesn't grab anybody anywhere else. That's kind of a nice way. Paint select tool right there. Now, with those faces selected on the top, now I'm going to start working this part down here. Edit mesh, extrude, because I need more geometry. So I go up like this, and I go, okay, it's coming up, but it's got to go out some. And it's a cylinder, right? So it's going to do the same thing on all sides. What's that trick we learned for making everything move out at the same time? Holding control and manipulating this axis up here. And it is blue in this instance, so it is the Z, but Y for, you know, all intensive purposes, up and down. So we scale and it goes out, right? And then we got to do another extrusion, right? Because if I just pull that up, I lose that part down there. So I obviously have to do another one. Edit mesh, extrude, pull it up, and this time I'm going to bring it in. So again, hold control, manipulate the Z, and bring it in. So now it goes from in to out to in. And then I can do another extrusion. And then this is where I'm going to bring it up to here. And then again, using control and the Z axis, I'm going to scale it out to match the sort of flare of this thing. And you can see, because I'm using the scale tool and I'm using control in conjunction with the axis that I don't want to manipulate on, everything stays evenly spaced. Does that make sense? And then I can do another extrusion, make a smaller face inside of a larger one. And then this is where I'm going to have to make this thing, you know, somewhat hollow because it is a jar, right? It's got an opening on it. So I have to extrude it. Now here's where this X-ray thing will come in really handy. And because again, you'll notice I don't just push it right down because that's not going to work. I have to extrude it down. So I go to edit mesh, extrude. And if I go straight down, you can see it's not really matching that well, right? You see the double shading? So what I'm going to do instead is I'm going to use control and this axis here and bring it in. And you'll see this thickness is the same all the way down. Does that make sense? That's much more like it would be because this is a ceramic jar, right? The clay that they fired in order to make this thing is going to be fairly uniformly thick. Does that make sense? So I have to actually build the interior of this thing as well. So now that I've got that in there, I can, again, I don't want to go straight down because then you can see it's tighter over here than it is there. So obviously that's not right. I'm going to have to do another extrusion and bring it down. So I go edit mesh, extrude, and now I take this one and I bring it all the way down to Chinatown. Again, maintaining, you'll notice that that thickness is the same because it should be the same thickness. So now I've got that whole object and it has all the details in it. Does that make sense? All right. So again, that's using just stuff we did today. Now, let's say we didn't want to do it that way. Could we do it another way? Absolutely. I could, if I wanted to, grab these vertices, everybody on the top, pull it up here to this detail, right? Get my insert edge loop tool, drop an edge loop here, and then put an edge loop here, and then scale it from the middle, and I accomplish the same thing. So it's not necessarily you have to use the extrude tool. You have to use it. It doesn't really make a difference. Nobody's going to ask you which tool you use. It's just a function of getting the components where you need them and manipulating them in the most efficient manner. Does that make sense? So there's not a right or wrong. But to make it hollow, you're definitely going to have to use the extrude tool to do that. It's way more difficult to do that with any other means. But you just model these things. And if it's not smooth enough, again, it looks more curved here. I'm making it very sharp. Well, then if you put more edge loops in there, right, put another one in there, and then manipulate those guys, absolutely. Again, scale tool, holding control. Does that make sense? So you can make any detail you want. It's just a function of manipulating the components. That's it. We create components and we move them around. Scale tool, move tool, rotate tool. That's it. Does that make sense?
Yep.
This is modeling. So when you go to decide what objects you want to build out of the level 1 folder, it's going to be like what you're seeing here. Insert edge loop tool, extrude tool, multi-cut tool. The difference is when I'm building a skill check, I set my project to my skill check file folder. When I'm trying to build an asset, I have to set my project to the specific asset I wish to build. So for example, if I take a look at my list of assets, we go to documents file, year and month, asset file folder, level 1 assets. Let's say I want to build the ladybug. Oof, brutally difficult. I would not suggest that one. It's so cute, but it's misleading. But let's say I decide to build the ladybug. So what happens is I have to set my project not to the level 1 folder, but to the ladybug folder specifically. So I go to File, Set Project. I go to my asset file folder. I go to my level 1 folder. I choose the ladybug, set, and then I go to File, Open Scene, and I choose the ladybug start file because that's what I start with. Don't save. Right, so now I have the ladybug. The images load up, and now I'm modeling that. Make sense? Hell yeah? Okay, great. So now you model these things in individual scene files because you're going to make 5 of them, so you're going to make a bunch. No, 3 of them for the first level 1. It used to be 5. So you're doing 3 of them, right? So you build them in their individual scenes, and then you're going to bring them into that scene with the columns. Remember I showed you there was columns that you put your objects on? And of course, if you want to make sure you're going to get maximum points, you want to make sure you're looking at your self-grade document, which should look like, oh, incidentally, here's the modeling parts guideline. Every object you're going to build and how many pieces it should be made of. Does that make sense? So make sure you're looking at that. And then our self-grade, which is, of course, on FSO, make sure you select week 1 because we are in week 1. This is your first turn in. And you'll see it lists exactly what we're looking for in terms of your grade. So it's really, if you follow this, you're going to do great. The only thing you could do is ignore this. That will kill you. But you can see silhouette. What did we say silhouette was?
The basic shape of it, you can tell what it is without seeing the details.
Absolutely. Silhouette is shape, seeing the object and recognizing it for what it is without seeing any surface details whatsoever. Now, form is 3D or depth related details, right? So surface details, that means when light is on it and we can actually see the object. Depth related details, all right? You'll see built-in parts. We talked about that today. Is it made out of the correct number of parts? All right. Edge looping and topology. We talked about that today. Does it look neat and clean, or is it messy and you know, crazy shading errors and problems? Layers. Do you have one layer for each object? You should have one layer for each object. So when you build the ladybug, for example, I built the ladybug. When you make that file, make a layer for it. Because when you take that ladybug and bring it into the file that has all the columns in it, the layers go with it. All that stuff goes with it. So you make it once and you got it. It's always there. So make it in that main file. Make sure it's got a layer. Again, the layer's got to be named. It's got to work. The object has to be on it. You know, those are all aspects of a working layer. So make sure that's on there. Presentation mode. We talked about make sure it's in wireframe. Make sure you delete the images. Who remembers how do you delete the images? How do you delete the images in a file? Does anybody remember? Anybody who wrote that down? How do you get rid of them? Once you're done modeling, I don't need these pictures anymore. They're really cute. Edit. Delete all by type. Absolutely. And then you go to, there we go, image planes. Does that make sense? So that's how you get rid of those guys. And it removes not only the images, but all the nodes associated with it. So it kind of clears the file out. So you got to make sure you're doing that. Did I name my file properly? Again, just make sure you save it with the correct name. The name for every assignment is written, where do you think? On FSO. If you look at the activity, I tell you what to call it. So make sure you give it the right name, because that's worth almost 10 points. Let me see. Let's see. If I did the assignment, the naming is worth 10 points. Literally, if you name the file wrong, you went from an A to a B. Does that make sense? Name it right, please. It is harsh, but you know what? We've got to grade you on this stuff. It is important. That's correct. Because what happens is when you guys are working, they give you will make a file with this and such number of faces. They will have this many triangles or quads. You will make sure to name it this, this, and this. Make sure your texture maps are no larger than this and such. And you must, like, literally, these are the rules for what we want you to do. And if you don't do what they ask for, you're only making things take longer, and you're not going to work there very long. Because you are either part of what makes the project go, or you're not part of the project. Does that make sense? Literally, there are too many people who want to do this work and will pay attention to every detail and do it exactly as they're asked for you to have that luxury. Does that make sense? You don't. You need to execute exactly the way they want it. And every little detail is worth sweating. Well, again, and the problem is the most valuable thing you own is your name. And you want your name associated with very hard work and following instructions to the letter, because that means you're going to work again. If your name gets sullied as somebody who kind of is a bit of a slacker, really late with the work all the time, doesn't do such a good job, people aren't going to call you. And it doesn't matter how good you are, they're not going to call you. Does that make sense? Because that's a variable they literally cannot afford. So you got to kind of build yourself into the person that they want, and then that will ensure success. So that's what we're trying to do here, is build you into what they want so that you will be more successful and you won't have to make a mistake to learn from it in the field. You know, much better to do that here. Does that make sense? Hell yeah? Okay, so make sure you're dialed in, use that self-grade document. If you're having trouble, go to the Google Hangouts. Have you guys seen that yet?
Yes.
You've looked at that? Okay, that's a very cool place. Please go. It's actually pretty fun. The Google Hangout, where you can get some help if you need it, online help. All right, so that's all I wanted to talk about today. Thank you very much, everybody. Yes.
I tried to do something different here, hiding the shape here.
Mm-hmm. Yeah, that's not bad.
It's not bad, but it's pointy.
Yes, but if you use the insert edge loop tool and put some more edge loops in there and scaled those out, it would be more rounded. Does that make sense? It's always more components, properly manipulated will give you more smooth curvature. Fewer components, it's more angular.
So you said something like going to mesh tools or mesh tools
Mesh tools, insert edge loop tool.
again.
Mm-hmm. And just drop an edge loop in there and then switch right to your scale tool.
Actually, oh. I don't know what is wrong now.
It's okay.
And it's sorry.
That's okay. But you just drop an edge loop in there, switch to your scale tool, and just scale those away from each other, and it's going to get more rounded. Yep, you can't help it. Yeah, go ahead.
Because every time I do this and I have to go around.
Right.
So like
Do you have a mouse?
I don't.
Because that's the problem.